Despite being one of the smallest tectonic plates on Earth, Juan de Fuca is responsible for some of history's most powerful earthquakes. The name megathrust should tell you everything you need to know. Megathrust earthquakes occur at plate boundaries, where one tectonic plate is forced underneath another. Like strike-slip earthquakes, subducting plate boundaries get stuck and build energy over time. When they slip, they release far more energy than your typical tremor. In fact, every earthquake of magnitude 9.0 or greater since 1900 has been a megathrust. The last time this happened at the Cascadia Subduction Zone was over 300 years ago, on January 26, 1700. We know this thanks to ghost forests found off the coast of the Pacific Northwest, along with historical tsunami records from Japan around the same time. Speaking of, a megathrust earthquake in Cascadia could easily produce tsunamis as high as 100 feet. And if that's not scary enough, try this. A megathrust quake generally happens in the region once every 500 years. It's been over 300 years since the last, meaning the area is just about due. Geologists refer to this event as the Big One, and believe it could be absolutely devastating to any coastal towns or cities. And it's not even the most dangerous place on Earth in terms of seismic activity. That honor goes to the Sunda Megathrust, a 3,300-mile subduction zone on the other side of the planet. Located at the convergent boundary of the overriding Eurasian plate and the subducting Indo-Australian plate, the Sunda Megathrust forms a half-moon shape around the western and southern coasts of the Indonesian islands. If you want a ballpark idea of the kind of devastation a megathrust earthquake in the region can cause, look no further than the 2004 Indian Ocean disaster. On the day after Christmas of 2004, a powerful 9.1 magnitude tremor claimed nearly 250,000 lives across 14 countries, with Indonesia suffering the most, followed by Sri Lanka, India, and Thailand. According to the USGS, it was the third most powerful earthquake ever recorded, behind the Great Alaska Earthquake in 1964 and the Great Chilean Earthquake in 1960, which measured 9.2 and a whopping 9.5 respectively. The 2004 event produced a devastating tsunami wave that ravaged the coasts of nearby countries. It traveled between 310 and 620 miles per hour across the open ocean before growing upwards of 100 feet in shallow water. Earthquakes in these megathrust zones trigger tsunamis by displacing water. The overriding plate, in this case the Eurasian plate, bends as it locks with the subducting Indo-Australian plate. When the pressure releases, the overriding plate shifts upwards, displacing the water. Oddly, the 2004 earthquake, and most of the seismic activity along the Sunda Megathrust, occurs along the northern segment, where the subducting piece of the Indo-Australian plate is actually shorter and much younger. Normally, this area would be significantly weaker than the rest, but recent studies have called that theory into question. According to researchers at Monash University, the deep Java slab acts like a giant anchor, dragging the rest of the plate and creating extreme stress levels near northern Sumatra.